So let's do this example. So say we have 5 grams of sodium hydroxide. It's added to a known volume and concentration of nitric acid. Calculate the mass of water that forms. Okay, so first step, write out our chemical equation. We have a base and an acid reacting together, so it makes sense we should get water and a salt. So we have our NaOH, and it actually says it starts as a solid and then we add it to HNO3 aqueous. Now, since it's a neutralization formula, I'm going to write my water as HOH to make the balancing simpler. So HOH liquid plus my salt, which is sodium nitrate, and that would be an aqueous. So when we look at the balancing, looks good, looks done. So it's all 1, 1, 1, 1. So that's nice. So now let's write down our information that we're given. So we're given information about sodium hydroxide. We have 5 grams. But we're also given information about our acid. So this is different. We've never had a question where we've been given 2 givens. So we have 2 givens and 1 wanted. So here's, we want to find information about the water. So now what I have to do is I have to look at this whole question and say, okay, I have these 2 givens. Which one is going to be my limiting reagent? So what you have to do is you have to find the moles of both of those reagents and compare them, okay? So let's go through one at a time. So find the molar mass of our sodium hydroxide. Grams per mole. Good, thank you. And then our moles will be our mass divided by molar mass. Okay. So now I can find the moles of my acid as well. So if C equals N over V, then N must equal C times V. So you get 0.00625. Oh, I added 1 too many zeros. Okay, so now this one is a little obvious because it's a 1-to-1 ratio, but I'm going to go through the process of setting up to kind of show you how to tell, just for practice. So what you want to think to yourself, okay, if I need 1 sodium hydroxide for every 1 nitric acid, then you can look at the moles and is it a 1-to-1 here? No. What can you see is the limiting reagent? This is my limiting reagent. So we can conclude that. And this is my excess. So say though you couldn't tell right offhand. Say it was like a weird coefficient. The way that you set up the ratio, and I'm just going to put it down here, is so you have like say one of them. So you have like your NaOH used divided by NaOH mole ratio, which is your coefficient, is equal to your HNO3 used divided by HNO3 mole ratio. Okay? So like if it wasn't obvious to you, this is how you set it up mathematically so that you can see which one is whatever. Okay, so here it'd be like 0.125 moles divided by 1 is equal to 0.0625 moles divided by 1. If it was different coefficients, then you would see, and whichever one is smallest is the limiting reagent after you do the calculation. Okay, so I'll show you an example of that next. So now, what we can do is we take these moles from our nitric acid and apply it to the water scenario. Okay, so now we know, okay, I'm going to use these moles, 0.0625 moles. And my molar mass of water, just have this one memorized, 18.02. Well, you don't have to have it memorized, it's just, you probably use it so much that generally you just start to memorize some molar masses. So you should get 1.12625 grams, two significant digits, 1.13. Okay. Any questions about that one? Okay, next one. Say we have a certain concentration and volume of acid and it's added to our base, what mass of water can form? So again, we're told another neutralization reaction here. So let's write it out. We have our H2SO4 plus our KOH makes HOH plus K3PO4. Is this one balanced? I mean SO4. Sorry, I was looking at my other example. K2PO4. I mean K2SO4. Oh my gosh, I'm sorry. Okay, I'm going to fold my paper so I don't look at that. That's better. Okay. Is it balanced? No. So at first blush here I see, okay, I have two H's on this side and only one H on this side. So I'm going to put a 2 here. I'm going to use red. Okay. Very good. Then I have my 2 K's, 2 K's, 2 OH's, 2 OH's, and I'm good to go now. Rock on. Okay. So let's use green for given. They both start with a G, so it's fun. Okay. So I'm given information about my acid. So my volume is 0.02 liters. My concentration is 3.0 moles per liter. And I'm given my volume 0.15 liters. 0.0. And my concentration is 5.0. Okay, so find the moles of each. Okay, so we have our 2 moles of our given, but it's not a 1-to-1 ratio anymore. So what do? Well, we have to set up our a ratio. So we take the moles of our acid given, or that we had, divide it by the coefficient, which was 1, is equal to the moles of my KOH divided by 2 now, okay? Because its coefficient from balancing is 2. So now, after doing this, so now put in 0.075 divided by 2. So what we have now is, I just want to scroll this down. Is you get 0.0375, right? Is 0.06 greater or lesser than that? So my answer here is 0.0375. My answer here is 0.06. So instead of an equal sign now, I'm going to put, which one is greater? Which number is greater? 0.06. So I'm gonna make a greater than sign there. So now I can identify if this mole, when I do my molar ratio, if this value is larger, that means this is the excess reagent. Okay? So this one is the one in excess. This one is the smaller one, so it's my limiting. Okay, my KOH. So now this is the mole that I use. Okay? Use this moles. Whatever moles you solved from it, not this one. Okay? Use this one. So now I do a molar ratio with my water. Well, it's a 2 to 2, so N is equal to N times 2 over 2. So my moles for my water is 0.075. And I'm asked what's the mass. So I know my molar mass is 18.02. Oh, I should have been using blue. So my mass is your moles times your molar mass, which is 1.3515 grams. So to sig digs, that's 2 sig digs, so 1.4. Okay. Getting the hang of these? It's kind of fun, right? It's a little bit more difficult than just our normal stoic, which I think you guys are totally ready for. So. All right, let's do the last example.